you. Can everybody hear me okay? Okay, great. Thank you all for coming. I hope you had a nice lunch. So again, my name is Katrina Uychaco, and I'm an engineer at GitHub, and I work on Atom, GitHub's free and open source text editor. But today, I'm here to talk to you about Electron. And so can I get a quick raise of hands before we start? How many of you, before hearing about this talk, had already heard of Electron? Awesome. And how many of you have tried building something using Electron? Also awesome. Any chance anyone here in the audience has tried to use Electron to control a robot? Yeah, we have one person. Okay, this is what we're going to do today. I've brought my trusty assistant, BB8 Sphero robot here, and he is going to help demonstrate some of the fun and interesting things that we can do with Electron. But first, we're going to talk about what Electron is and how it came to be. So Electron is a library that allows you to build cross-platform desktop apps using web technologies, JavaScript, HTML, and CSS. And it was born out of GitHub's desire to build Atom, its free and open source text editor. And again, this is what I have the pleasure of working on. And GitHub decided to build Atom using web technologies, because the dream was to build the ultimate tool for writing software, so something that was highly customizable and hackable, much like Emacs and Vim, but packaged in a nice, beautiful, easy-to-use GUI. So no matter where you're at, whether it's your first day writing code or you're an experienced hacker, Atom is designed to be a tool suited to your needs. Thus, Atom was written in the languages of the web, and because while native desktop UI technologies come and go with time, the web is a standard that becomes more capable and ubiquitous with each passing year. So it made sense to write Atom in a technology that was approachable and accessible to many, and Atom was written in web technologies and open source so that anyone could hack on it. And GitHub realized that the technology used to enable Atom to be built in HTML and JavaScript would be useful to other developers. So Electron was extracted from Atom core and open sourced as its own library, made available to the public. So Electron. So Electron is a library that combines Chromium, which is the main part of the Chrome web browser, and Node.js to allow you to build desktop apps that run across Mac, Windows, and Linux. And it's a library that, and it aims to make the hard parts of desktop app development easy, like managing automatic updates, dealing with native operating system menus and dialogues, handling crash reporting, and profiling and debugging. And if you're a web developer, you're probably familiar with the pain of dealing with cross-browser compatibility. But with Electron, all you need to do is develop for Chrome, and you have an application that works across platforms. And Electron is kept very up to date with the latest versions of Chromium. So whenever there's a new version of Chromium, the Electron team works hard to release a new version of Electron that uses it within a couple months or so. So you get access to all of the latest and greatest Chromium features. You can use most of the ES6 features, and you also have CSS variables and source maps that come right out of the box. And since each Electron app window is just a Chrome page, you have access to Chrome's powerful debugging tools. So this is Atom, and you can see that on the bottom we have DevTools open. You can use the timeline, take heap snapshots. You can do interactive debugging. And these are all extremely helpful while building desktop apps, just as they are while building web apps. So as I mentioned, Electron is free and open source, and it's being used to build a variety of different types of apps There are several editors in addition to Atom, the Brave web browser, chat clients. It's being used at companies like Microsoft, Facebook, Slack, and Docker. And so now let's talk a bit about how Electron works. We're going to talk about it in the context of the app that we're going to walk through today. So like I mentioned today, we're going to build an app that we will use to control BB8 here. And when we start the app, the process that is started is known as the main process. And you can think of this as a typical node process, but with additional Electron APIs that allow you to control components of your operating system's UI. So we can do things like add an icon to our menu bar. And when we click on this icon, the main process will then create a browser window. And this browser window will have an associated renderer process. And you can think of the renderer process as basically a typical Chrome page, but with node integrations built right into it. And you also have other Electron APIs available to you in the renderer process. You can create as many renderer processes as you like. And you can even create an invisible renderer process that just executes JavaScript in the background and doesn't affect the performance of your application. And in our app today, our main process will also be connecting with BB8 through Bluetooth. And so now let's take a closer look at all of these processes. Like I mentioned, the renderer process is associated with the UI of our app. And we're just going to have a few buttons. It's going to be a menu bar app. And when you click the button, then BB8 is going to do something fun and entertain us a bit. So the question is, how do the two processes, or the main process and all the renderer processes, interact? Well, all the processes are completely isolated. So the only way to communicate between them is through IPC, or inter-process communication. So when we click on the button that tells BB8 to do a dance, we're going to send an IPC message over to the main process from the renderer process. And then the main process is going to communicate with BB8 over Bluetooth and have him do a little dance for us. OK, so it's time to look at some code. And first off, I want to mention that all of the code is already up on GitHub. It's a repo under my username, Uychaco. And you can feel free to take a look at this, and you can look at the commit history to see how the progression of how the app was built, and use it as a way to familiarize yourself with Electron and maybe help you get started with building your own fun Electron apps. So we've got Atom fired up, and for the sake of time, I'm going to be checking out commits that I've tagged, and we're going to be taking a look at the code. I've aliased my git checkout as GCO. So we're going to start out with hello, a commit tagged hello. And we start out as we would any node program with a package JSON. And we've got some dependencies that I've already installed, and a start script that runs the bundled Electron binary, and we pass it the path of this project. And when Electron starts, it looks in your package JSON to figure out what the entry point of your app is. And ours is a file called main.js. So it takes this code and it runs it in the main process. And our main.js code right now is pretty simple. It's the simplest Electron app that you can conceive of, your typical hello world type of app. You can see that we're using ES6 here. No transpiling. We just get it right out of the box because we're using the latest version of Chromium. And so we've got Node, and we've also got Electron APIs. So the app module controls the application's event lifecycle, and it emits a ready event when Electron has finished initializing. So when the app is ready, we're going to create a window, and we're going to use the browser window API and specify the dimensions that we want the window to be. and load our HTML. So here we've created a renderer process from our browser, a renderer process from our main process. And if we look at that index.html, it simply says hello world for now. And we're printing out versions of Node and Chromium and Electron that we're using. And you'll notice that embedded in our HTML, we have Node. We have access to all of Node's built-in modules and APIs. We also have access to any module that's up, any of the 330,000 packages that are up on NPM. And this is really powerful. If we look at what's in renderer.js right now, simply a console log that says hello from the dev tools. And we're going to start up this app with npm start. And there we have it. We have a simple desktop app and can pop open the dev tools. We see our hello from the dev tools. And you can see that with very little, we've got an Electron app up and running. If you already are familiar with web technologies and Node, you can get to this point really quickly. So the next step is we're going to turn this into a menu bar app. And I'm going to check out another commit. And now in our main process code, we're also going to use the tray module provided by Electron. And this module will place an icon in our menu bar. So on Mac, it's going to be on the top right. If I was on a Windows machine, it would be on the bottom right. And we're going to use this Electron positioner module to place our browser window right underneath the icon. And what I want to point out about this is actually a third-party module. It was created by someone out in the community. It's not created by an Electron team member. And like Atom is open sourced and has a thriving open source community, Electron does as well. And there are a lot of great packages out there. Electron actually has over 400 open source contributors at this point. So we're going to use this awesome module. I think it's made by Jans in Sweden. And now when our app is ready, instead of creating a window, we're going to create a tray icon. We'll pass the path to the icon, and when we click on the icon, we're going to toggle the visibility of our window. And Electron provides us the tray bounds so that we know exactly where on the screen the icon is, and we can position our window accordingly. So we'll pass those through down to show window, and use the positioner module to calculate the position to set our main window at. And then we'll show the window and focus it. And now when we create our window, in addition to specifying the dimensions, we're also going to indicate that we want it to be hidden at first, and we want it to be frameless, and we won't be allowing the user to full screen the window or resize it. And when we click away from the window and we get the blur event, we're going to hide it. And lastly, we're going to hide the dock icon that would normally appear on a Mac. So let's start this up again. And you can see now we have this little BB8 icon up in our menu bar. And we can click on him to toggle the visibility. And still have the dev tools. So you'll notice that I restarted the app entirely. And one thing to recognize is when you're working with Electron apps, if you change any of the code in your main process code, you're going to need to restart the app entirely. This is because that code is loaded into memory upon initialization when you first start Electron. Whereas if we had only changed code in the renderer process, then all we would need to do is refresh to see those changes, as is the case with any web page. So now we have a menu bar app. It's pretty plain. So we're going to throw some styles at it. And I'll check out another commit. And now when we click on the app, we'll see that we've turned our Hello World app into a Hello BB8 app. So we want to do BB8 justice here. OK, so now the exciting part. We're going to hook everything up so that when we click a button on our UI, That ultimately ends up in BB8 here doing a little dance. So, and if you recall, we communicate between processes through IPC. So now we've added a button in our index.html and it has an ID of dance. And in our renderer process code, we add a listener that uses the IPC renderer module that we get from Electron, and we send a dance message over to the main process. And in our main process code, once the app is ready, now we're going to use the IPC main module from Electron, and when we receive the dance message, we'll have BB8 do a dance. So now the question is, how do we hook up BB8? And for that, we'll check out another commit. So BB8 here is built by Sphero, and Sphero has a handy node module that we use. It uses a Bluetooth library called Noble, and all we need to do is pass the UID of BB8, and we have this BB8 object that we can use to control the robot. I've also created a separate file, BB8 commands, that has all the commands that we'll be using today. And now when the app is ready, we're going to connect to BB8 and print something to the console and have him change a random color just so that we know he's awake. And now when we get the dance message, we're going to call our dance command. And we'll take a look at that. So it's pretty simple. It just sets a couple of intervals and has BB8 roll in for a random distance in a random direction and change a random color. And we also want to play some music for BB8 to dance to. So we're going to use the audio API, and we're going to send a sound message to our renderer process and the name of the file, the sound file that we want to play. So again, we're using IPC, sending sound to the main process, or the renderer process. And when we receive that message and the name of our audio file, we're going to play the song. Okay, so now comes the moment of truth. See if we can get BB8 to dance for us. But first, since BB8 is so small, I brought a webcam so that everyone can get a better view of his dance moves. And I have another menu bar app that was created specifically for this presentation. It's another Electron app that uses WebRTC to display the feed from a given webcam. So hopefully y'all can see BB8 better now. And I'll stick this down here. Okay, now for the moment of truth. Pray to the demo gods that this works. Wait for BB8 to connect. And there we go. And we see he's turned to pretty blue, and he's ready for some dance moves. Okay, so now we see that we have our dance button, and when we click it, BB8 dances. Thank you. All right, so you can see that pretty quickly we were able to throw some code together and control BB8 here. And we can have him do more than just dance. So check out another commit and start the app. So we can also turn BB8 into a disco BB8 ball, have him change some pretty colors and spin around for us. And we can also use BB8 as a magic BB8 ball. And for those of you who aren't familiar with magic 8 balls, they're basically these toys. They're kind of for fortune telling, and you can ask them simple yes or no questions and shake them, and they'll give you a response. So We can ask BB8 questions like, BB8, do you think that we'll have any luck seeing the Northern Lights tonight? And see if he says yes or no. Okay, he's not very optimistic. But we can be hopeful. Let's see, let's ask him, BB8, are you having fun today? Huh. Okay, maybe after this next portion you'll be having fun. Let's see if we can get him to say yes, because I want you to hear that. Yeah, okay. So, magic BB8 ball. And lastly, there's a way for you all to interact with BB8 by tweeting at him. And I'll tell you exactly how. If you want to take out your phones, tweet at him. One lucky tweeter is going to get a free GitHub shirt, so a little extra incentive there. And we're going to take a look at this code before we do this. So we're going to be using the Twitter API. We have the Twitter NPM module, and I have code that will get me a random tweet. And if you tweet at BB8, we'll be looking for tweets with the hashtag BB8 Electron, all one word, lowercase. So tweet at BB8, and you can either ask him to dance or disco. And once we get a tweet with a hit, he will do the thing that was said. And we'll also be displaying a desktop notification that says the name or the username of the person that tweeted and shows their profile picture. And so go ahead, tweet now. We'll give it a bit because it does take some time for the tweets to come through. And I'll get the webcam back up so we can still see BB8. Okay, so I'm going to click the button now. It's going to give it another like 10 seconds, so you still have time. And actually, first I'm going to turn my notifications back on, otherwise we will not see the notification that comes through. Also, let's take a look at so the way that we display the notification is we use the HTML5 notification API, which we only have access to in the renderer process. So what we need to do is from our main process code, send the information about the tweet to the renderer process. And when we get this tweet found message, we're going to use the notification API. So another instance of IPC. All right, so I think we have some tweets in, and let's see what we get. A little bit more time. You still have more time to get tweets in if you want. And the winner is Elert Smari. Says to disco. All right. And there he goes. So I'll tweet back at you and let you know how you get your free GitHub t-shirt. So that's it for the BB8 show today. Thank you all for coming, and I'll throw another slide up with the resources, with a list of resources in case you want to get started with Electron and learn more. And here we go. My contact information is on the bottom right if you have any questions. And thank you all for coming. Hope you had fun with BB8, and good luck building your own Electron apps.